Graphical representation of motion. A graph is a pictorial representation of the relation between two sets of data, of which one set is of dependent variables and the other set is of independent variables. In a displacement time graph, displacement is a dependent quantity taken on the y-axis and time is taken on the x-axis as it is independent. If the position of an object changes with time, it is said to be in motion. If an object has equal displacements in equal intervals of time, then the graph is a straight line inclined with the x-axis, which represents uniform motion of the object. If the graph is a curve, it represents non-uniform motion. The slope of displacement time graph gives velocity of the object. We will go through this in detail after a short interactivity. Distance time graphs. Equation for position velocity relation. The third equation will be obtained from these two equations. From the velocity time graph, distance traveled s is equal to area of the trapezium OABT. This is 1 upon 2 into B1 plus B2 whole into h, which is equal to 1 upon 2 into OA plus BD whole into AC. Substituting OA by U, BD by V and AC by T, we get S is equal to 1 upon 2 into U plus V whole into T, equation 1. But we know that A is equal to V minus U whole upon T, or T is equal to V minus U whole upon A. Substituting the value of T in equation 1, we get V square minus U square is equal to 2AS. 2AS is equal to V plus U into V minus U. V plus U into V minus U is equal to 2AS. By using the identity A square minus B square is equal to A plus B into A minus B, we get V square minus U square is equal to 2AS. This is the third equation of motion. Uniform circular motion. Uniform circular motion describes the motion of a body traversing a circular path at a constant speed. The distance of the body from the axis of rotation remains constant at all times. As an object moves in a circle, it is constantly changing its direction. Merry-go-round is an example of uniform circular motion. Satellites orbiting our Earth, artificial satellites or our moon, have motions that are very nearly uniform circular motion. The planets that orbit our Sun have motions that are very nearly uniform circular motion. Assessment. Now time for an interactivity. Click the correct option. Did you know? Sir Isaac Newton is one of the most influential scientists of all time. He came up with numerous theories and contributed ideas to many different fields, including physics, mathematics, and philosophy. Born in England, Isaac Newton was a highly influential physicist, astronomer, mathematician, philosopher, alchemist, and theologian. Newton's 3 laws of motion relate the forces acting on a body to its motion. Johannes Kepler helped lead a scientific revolution in the 17th century with his amazing work in the field of astronomy. Among his many contributions were the 3 laws of planetary motion. Summary. Let us summarize what we have learned. Motion is a change of position. It can be described in terms of the distance moved or the displacement. The motion of an object could be uniform or non-uniform depending on whether its velocity is constant or changing. The speed of an object is the distance covered per unit time, and velocity is the displacement per unit time. The acceleration of an object is the change in velocity per unit time. Uniform and non-uniform motions of objects can be shown through graphs. the motion of an object moving at uniform acceleration can be described with the help of three equations, namely, v is equal to u plus at, s is equal to ut plus 1 upon 2 at square, 2as is equal to v square minus u square, where u is initial velocity of the object, which moves with uniform acceleration a for time t, v is its final velocity, and s is the distance it traveled in time t. If an object moves in a circular path with uniform speed, its motion is called uniform circular motion.